All right, this second section in the honors textbook is really, really big. So in the videos, I break them down into more sections than that to kind of help you compartmentalize things. But basically, it's going to delve into the definition of chemistry a little bit more. And that is chemistry is the study of matter and the changes they undergo. So, how do we divide up and categorize everything? Matter is everything. Anything that has mass and takes up space. So everything around you, from the tricycle that you rode as a kid to the waterfall, the rocks, the grass, the Amazon package that comes, the hot air balloon, solid liquid gases, plasma, everything in between, that is all covered under matter. So if somebody says you don't matter, they're saying you don't exist. Horrible insult. All right, but when you take a look at matter, you have to account for how much mass it has. Mass is the amount of matter the object has. So you'll see mass and matter are used in each other's definitions. They are cyclical. You can't have one without the other. All right, so that's one of the big things that we're going to talk about in this video right here. Okay, now mass is not the same thing as weight. Okay, weight is going to be the effect of the gravitational force on matter. So it depends on what celestial body you are on, whether you are here on the Earth or whether you are there on the moon or over here with Mars. Who knows one day if we're going to get to Mars. Okay, so when it comes to this gravitational force, okay, on Earth, the force due to gravity is 9.8 meters per second squared. That's the acceleration due to gravity. On the moon, it is 1/6 that of our gravitational force on Earth. So what does that mean? That means that you are going to weigh less on the moon. You don't take up less space. You won't change your mass. You just change your weight. Now, back when I started teaching in 2002, before Google was real big, there was a website, onlineconversion.com, and I was clicking around it to try to figure out ways to help my kids convert stuff and metric system and all that, and I came across this. So if you go under the fun stuff tab and scroll down a little bit, there's weight on other planets. You enter your weight here, so I entered 125 pounds. This is our American system. And then you hit calculate, and then it tells you what your weight is on other planets due to their gravitational pull. All right, so for Mercury, you would weigh 47.25 pounds. If you were on Venus, you'd be 133. 1/6 of Earth's gravity on the moon, you would weigh 20 pounds. That's why when you see the videos of people walking on the moon, it looks like they're bouncing, okay? That's because you're used to a certain amount of force pulling down on you, so that means that you would bounce. All right, Mars is going to have less gravitational pull than that of Earth, so it would be 47 pounds. You wouldn't be as bouncy as the moon, but you would be pretty bouncy. So you're about like a third of what you weigh here on Earth. So when you watch Matt Damon in The Martian, which I'm like the worst to watch sci-fi movies with because I'm like, yeah, that's not possible. Yeah, that's inaccurate. Oh, that's not possible. My husband like wants to like strangle me when I watch them with them. All right, that's inaccurate, and that makes me very sad. All right, Jupiter, you would be 295, almost 300 pounds. So what would that feel like? If you're bouncy with less gravity, you are going to be weighed down. So if you've been on like the Gravitron at June Fate or something like that, and you're like pressed against the walls, you're going to experience more G's. That means that you are going to be pulled down, and you would actually get really, really, really heavy, and it'd be really hard to breathe. Okay, Saturn is about that of Earth, the gravitational pull, even though, we couldn't really survive there. That's 114 pounds. Uranus, she said Uranus, is 111. Neptune is 140. Pluto, back when it was considered a planet, would only be 8 pounds. Oh, that's so cute. You would like fly off when you walked. All right, and if you could survive the surface of the sun like poor dear Icarus, all right, you would be 3,384 pounds. You would be condensed down into this teeny tiny little box of you in the most compacted way possible. Okay, you would not be able to survive. Besides the fact that it would be so hot that you would probably vaporize, but yeah, you couldn't make the gravitational pull either. All right, so we're going to end this video with an introduction into the classification of matter. And then the rest of the videos in this playlist are going to talk just about that. So the classification of matter takes everything, okay, everything around us and breaks them up into two main sections. The one section is pure substances, and the other one is impure substances or mixtures. I call them mixtures because impure just sounds dirty. Ugh. All right, and then it takes each of those two subsections and breaks them up even further. Pure substances are broken up into elements and into compounds. So we'll start the beginning of the year talking about elements and the middle of the year talking about compounds. Okay, the impure substances or mixtures are also broken down into homogeneous mixtures and heterogeneous mixtures. Homogeneous meaning that they're going to be the same throughout and kind of uniform, like a saltwater solution, an alcohol solution. Tap water is not a pure substance. And heterogeneous means different. So that means things like soil, wood, cheesesteaks, whatever. Okay. And then we'll talk a little bit about down here when we get into our elements at the end of this playlist. Talk about metals, talk about non-metals, talk about our metalloids, and we'll talk about our noble gases. Okay, so I'm sure you know that silver is silvery in color. And a metal, it's going to conduct electricity. This is the European way of spelling sulfur. It should be an F here in the United States. Metalloids are going to have properties of both metals and nonmetals. That's like your arsenic. And then the last column of the periodic table is going to be our noble gases like helium that are very non-reactive. All right, so we're going to visit this graphic a bunch of times throughout the course of these videos to try to help you organize all of our information. All right, so stay tuned and check them out.